Okay, Algebra 2. Today we are reviewing, should have a sheet that looks like this that says operations with polynomials. So on the one side we're reviewing polynomials. On the back side we're doing radical equations. Okay, so that's like the square roots and the cubic roots and stuff, and we're solving for those. Okay, so I've kind of circled a couple problems like the ones in blue that I want to do together with you, and then what we'll do is we'll just do the remaining ones for homework. Okay. So, I don't know, the ones up here at the top we're adding and subtracting, and these are polynomials, and we are, like on number 1, there's a plus sign, so that means you're adding those together. Here's another addition one, here's subtraction, okay? This one is another addition, but you're adding 3 of them together rather than just 2, and here you're subtracting 2 of them. So I chose to do the bottom 2, like the 5 and 6 problems, because they're the longest ones, and hopefully that'll give you an idea of how to do 1 through 4. So starting with number 5, when you are adding polynomials together, I guess let's look at number 6 real quick, like thinking about when you're subtracting, we do know that we have to distribute that negative through to the back pieces. And you kind of do that same thing with a plus sign as well, like you're adding this, you're adding that, and you're adding that. But we know that addition doesn't change the symbol. So like if this is 8x squared, it'll stay 8x squared. If this is negative 2x, that'll stay negative 2x. The plus isn't going to flip the sign of it like a negative does. So really what's happening is when we are adding those all together, we can kind of just drop these parentheses off and then just combine like terms when we're going through, okay? So let's just pretend that those parentheses are not there. You can rewrite the whole thing if you want to, but just remember that like when you're adding, the sign's not going to change, okay? All we have to do is combine like terms. So I'm going to go through here very carefully. I'm going to underline how many terms we have to begin with. So I have 1 piece here, 1 piece here, 1 piece here, 1 piece here. That's 4 chunks or four terms. This one has 3. This one has 3. Okay. So we've got to combine all, 10 of those together somehow, some way. And we are going to start with the highest power. So I see an x to the 3rd power, and I think that's the highest. And I have another x to the 3rd power. Okay. And I think that's all my x cubes. So we start with a negative 8, and I'm going to add to that a negative 3, and negative 8 and negative 3, because they're both negative, we're going to add, and that's negative 11x to the 3rd power. You don't add the exponents. We're not like multiplying, or this doesn't become a 6, right? That stays x to the 3rd power, and then I'm just going to cross them off, okay? Then we move down to the 2's, okay? So negative 9x squared, and 8x squared, and 4x squared. So negative 9 plus 8 is going to be negative 1. And then negative 1 plus 4 here is going to be 3. So I have a positive 3x squared. Okay, this should be hopefully coming back to you. And then the next one I have is just x. So we're moved from x squared to x. So I have x. I have a negative 2x. And I think that's all. X and negative 2x, this is like a positive 1. So positive 1 minus 2 would be negative 1x, or just negative x. Those are done. And then the last thing that I have is a positive 2 plus 4 minus 1. So 2 plus 4 is 6, minus 1 is 5. So that's plus 5. And that is combining all of my like terms. Okay, I'm just adding those all together. All right? Okay, so 6, I just kind of said a little bit ago that we have to distribute that negative through everything behind it. All 3 of these pieces have to get like their sign flipped. Okay, so I'm going to rewrite this. This 12x minus 8x squared plus 6, he stays the same. There's nothing that changes there, but minus a negative 8x squared is going to become plus 8x squared. Okay, minus a negative 3x is going to be plus 3x, and then minus a positive 4 becomes negative 4. Okay, so everything's flip a sign that is behind the negative symbol, and then we just have to combine like terms. So my highest power is negative 8x squared and positive 8x squared, and those are going to cancel each other off, and so we don't have an x squared term. Then we move on to 12x and then plus 3x, so that's going to be 15x, and then I have 6 minus 4 will be plus 2. So that one simplified kind of nice at the end because everything canceled out. Okay, so that was 5 and 6. That was adding and subtracting. Okay, now we're going to go down to multiplying. Okay, so in number 8, we are multiplying, but we have just one piece being multiplied here to these three pieces, okay? So all we have to do is just distribute. We don't have to do like the FOIL method or anything like that. We're just distributing the 5x through there, okay? So 5x times 4x squared, 5 times 4 is 20, and x squared makes x to the third power, okay? So we like add those exponents, like this is to the first power, that's to the second power, x to the third. Okay, then 5x times negative 2x is negative 10x squared. And 5x times 1 is just 5x. And then there's nothing, none of those three will go together as like terms. So I just circle him and he is done. Okay? That was just a distributing. You're just distributing the 5x through. Okay? Let's bump on down to number 10. This is going to be a FOIL problem. Whoa. Oops. Okay, number 10. FOIL problem. FOIL. All right, if you forget what FOIL stands for, F stands for the first pieces. So like the first piece I see here is 3x. First piece I see here is x squared, so I'm going to multiply those together. So 3x times x squared is going to be 3x to the third power. Okay, then the O stands for the outside pieces. That's 3x and 2. So like the two outside pieces. 3x and positive 2 makes positive 6. Excuse me, positive 6x. Then we've got the I, which is the inside pieces. So 5 and x squared is plus 5x squared. And then the L is the last pieces. So 5 is the last piece here and 2 is the last piece here, which multiplied makes 10. Okay, the only other thing that I will do to this is I'm going to put these two, I'm going to flip these two around so that it's in order. So 3x cubed plus 5x squared plus 6x plus 10. And there we go. So he is all the way done. Okay, you can combine like terms if you are able to, but in this one I wasn't able to, so I just rewrite them in order. Okay, all right, the last one for polynomials that we'll do is this one. This is another multiply one, and this is kind of like the FOIL method, but it's not really FOIL because you have like two pieces here and you have three pieces here, right? Okay, so two pieces and three pieces makes a total of, if I multiply those together, 1, 2, 3, 4, 5, 6. 2 times 3 is 6. So I know that when I'm done, before I combine my like terms, I have to have 6 pieces. So the first thing I'm going to do is 4x squared times 6x squared. 4 times 6 is 24. X squared times x squared is x to the 4th. Okay, then I go on to the 4x squared and 9x, and that is a positive 36x to the third power. I'm running out of room, so I'm going to scoot these over. I just am writing too big, I guess, or something. Okay, so there we go. All right. Next, 4x squared times negative 3 is negative 12x squared. All right. And now I move on. I'm done with the 4x squared. Now I'm going to move on to the minus 2. Minus 2 times 6x squared is negative 12x squared. Negative 2 times 9x is negative 18x. And then negative 2 times negative 3 is a positive 6. Okay. Now, I'm done multiplying, but now I still have to combine like terms if I can. So I'm going to go, and this is my only x to the 4th power. So I'm just going to rewrite him. He's done. I have only this one for x to the 3rd, so plus 36x to the 3rd. But then I have negative 12x squared minus another 12x squared, okay? I should circle those a little bit better so I can see the symbols there. Negative 12 and negative 12 makes negative 24x squared. They don't cancel out because they're both negative. If one was negative, one was positive, they would cancel. And then I've got minus 18x plus 6. Those go by themselves as well. So that is combining all my like terms. Really the only two that I could combine were these two. So that's kind of like the FOIL method, the same idea, but it's not FOIL because I have 6 terms instead of just 4, like FOIL, right? But the same idea. So that was number 11. So do the remaining problems that are on this sheet for polynomials, and let's go on to the back side. This is radical equations. We're solving these. The 3 that we're going to do together are 1 and 2 and 9. I think number 1 might have gotten cut off, like the number 1 symbol. So anyway, that's number 1. and we are solving radicals. Okay, the first thing that you want to make sure and do is get the square root by itself. Now this one is kind of an odd one because it has a square root on both sides, okay, but it's interesting to note that like the square root is by itself, like there's not a 2 over here or like a +7 or something that I would have to subtract to the other side or move to the other side. So they are each by themselves, and to get rid of a square root, I just square it, right? So a square and a square root just cancel each other out because they're inverses, square and square root. So the x plus 2 kind of like falls out of the square root. And since the 3 is inside of a square root, that same thing happens to the right side. So I just have the 3 kind of falling out of there, and then all I have to do is solve for x. So I'm going to subtract the 2, and I have x equals 1, okay? Now if you want to, you can plug your 1 back in and solve. So like 1 plus 2 gives me 3. So the square root of 3 equals the square root of 3. That's true, right? So that would only make sense. But x equals 1, that's what I get for an answer, okay? Now number 2 doesn't have a square on this side, okay? But we're just going to make sure that this guy's by himself, like the square root's by himself, so I don't have like a number out here that I need to divide over, or I don't have like a plus something on the end that I need to move over to the other side. So he is by himself, so I can go ahead and square here and square here, okay? Now the square and the square root are going to cancel just like they did on the other one. So I have 2x plus 15 just falls out. But 6, since he's not inside of a square root, we will have to square the value of 6. So that'll become 36 on this side. And then I just do my math like normal. So I'm going to subtract the 15. 2x is equal to 36 minus 15 is 21, I believe. And if we divide by 2, x is equal to, that'll be like 10 and a half, so 10.5. And I don't care if you write your answer as 10.5 or 10 and a half. You could actually leave it as 21 over 2 if you want to, since that is completely reduced. So whichever way, it doesn't matter. They all mean the same thing. So that was number 2, okay? The remaining problems here are kind of similar to each other. We're going to go down and do a different one. That is number 9, because this one has a couple different things that are going on. First and foremost, we have this 7 here that we need to take care of, but also this is a cubic root and not just a square root. So we're going to address that as well. But first thing we need to do, regardless of whether it's a cubic root or square root, we need to get it by itself. So like this needs to be by itself. We have to subtract the 7 over to the other side. So I will have the cubic root of 2x plus 1, no, minus 1, excuse me, equals, and that side will be 3. And then to get rid of a cubic root, instead of squaring, you're going to cube it, right? We're going to take it to the 3rd power, and that will cancel the cubic root. So I will have 2x minus 1 equals, and I will have to figure out what 3 cubed is, because that one doesn't have a root to cancel, so I will have to cube the 3. 3 times 3 times 3 is 27. Okay, now I just do the math like normal, so I'm going to add the 1, and I'll have 2x equals 28, and then divide by 2, and that comes out nicely. I think that's 14. Okay, so same thing with the rest of these. You know, do all the algebra, get the radical by itself first, and then either square it or cubic, depending on what you need to do, and that should be it. Okay. There you go.